Welcome on the submodule 2 Collaboration and Networking. In this submodule, we will cover the following topics: circular innovation, principles and assessment tools, food upcycling, the valorization of byproducts and waste, with industrial examples such as a beer made from unsold bread and flour made from fruit waste. Food redistribution, logistics models, partnership with food banks and relevant regulations. New technologies for sustainability, food waste and loss. Industrial knowledge sharing, digital platform, supply chain consortia, and open innovation. Let's get started. The concept of circular economy is one of the cornerstones of reducing food waste and improving environmental sustainability. The circular economy, applied to the food sector, aims to maximize the use of resources and reduce waste at every stage of the value chain. The model is based on principles such as reuse, recycling, regeneration, and design for durability. The circular economy applied to the agri-food sector aims to overcome the traditional linear model of produce, consume, dispose by promoting regenerative systems. It encourages efficient use of natural resources, reduction of food waste, and recovery of byproducts along the entire value chain. In the food sector, this implies redesigning production processes, packaging, and logistics to close material and energy loops. The valorization of organic waste through composting, bioenergy, or development of new ingredients is a key element. The circular approach integrates technological innovation, sustainable business models, and collaboration among supply chain actors. As a result, the food system becomes more resilient, competitive, and aligned with global sustainability goals. Sustainability assessment tools enable the systematic measurements of our environmental, social, and economic impact of the product and activities. In the agri-food sector, these tools support strategic decision-making based on quantitative and comparable evidence. LCA and SROE represent two complementary approaches, focusing respectively on environmental impact and social value creation. They help companies and policymakers identify critical issues and opportunity along the value chain. The combined use of these tools promotes an integrated view of sustainability. These allow investment and innovation to be directed toward truly effective and responsible solutions. Companies that adopt circular strategy not only improve their environmental performance, but also strengthen their reputation and competitiveness in the global market. Food upcycling, making the most waste and byproducts. Upcycling is one of the most advanced sustainable innovation strategies, as it transforms waste or surplus into new products with high added value. This approach requires close collaboration between researchers, food technologists, and food designers to ensure safety, appeal, and sustainability. Upcycling not only reduces waste, but also contributes to the diversification of the product portfolio and the creation of new market niches. Furthermore, it stimulates the adoption of systemic design and open innovation approaches. Some examples of upcycling are flours made from fruit peels, fermented beverage made from cereal used as raw materials, and cosmetic that use vegetable waste. This type of effort requires close cooperation between scientists, food meal technologists, and product designers to preserve safety, attract attention, and maintain durability. Upcycling contributes not only to waste reduction but also to product diversification and the establishment of new consumer segments. It also promotes the adoption of systemic design and open innovation approaches. Food redistribution refers to the set of practices aimed at recovering safe and edible food surpluses and redirecting them to social purposes. It integrates logistic cooperation between public and private actors and a solid regulatory framework. It is a key tool to reduce food waste and address food insecurity. The topic combines environmental sustainability, operational efficiency, and social responsibility. The redistribution of surplus food is a key strategic for combating waste and improving social equity. The most effective models are based on partnership between companies, non-profit organizations, and local institutions. Food banks act as intermediaries for the collection and distribution of products that are still fit for consumption but excluded from commercial channels. The logistics of redistribution require digital traceability systems and careful planning to ensure safe and timely delivery. Logistic models define how food surpluses are collected, stored, and distributed. Solutions range from centralized systems to decentralized, community-based networks. Cold chain management is crucial to ensure food safety and quality. Digital platforms improve supply matching, and traceability. Performance indicator, time, cost, waste avoided, guide system optimization. Partnership with food banks connect producers, distributors, and non-profit organizations. Food banks act as a logistical hubs and territorial coordinators. In Italy, networks such as Banco Alimentare play a central role. Agreements define quality standards, responsibilities, and information flows. Stable collaboration increase recovered volume and service continuity. Regulation establish safety requirement and liability along the supply chain. At European level, the policy framework of the European Union promotes food waste prevention. National laws encourage donation and simplify administrative procedures. For instance, Italian legislation, Legge Gadda, and European regulation encourage such practices by offering tax benefits and procedural simplification. Hygiene and food safety guidelines protect both donor and beneficiaries. Regulatory compliance is a prerequisite for scaling redistribution models. To summarize, food redistribution is a strategic skill for companies and institutions operating within the supply chain to be aware of funding options and prepare projects in line with European objectives in order to have and exploit funding opportunity and prepare them accordingly. New technology at the service of sustainability. Innovative technologies that are most useful in waste reduction initiative. The most useful new technologies are smart sensor and the Internet of Things, IoT. The IoT can improve the industrial transformation process through sensors and continuous monitoring using IoT sensors for gas, temperature, etc. The aim is to reduce the deterioration of goods during storage or transport or even preservation within the point of sale, including through the possibility of setting and enabling alarms and alerts. Alarms and alerts can enable rapid intervention on the issue at hand, and the use of these technologies has already shown in many cases a measurable reduction in case of deterioration or waste, mainly using telemetry and dynamic control elements that respond in real time. IoT sensors enable the continuous monitoring of critical parameters such as temperature, gases, and humidity. Alarm systems allow for rapid intervention when anomalies occur during storage and transportation. Real-time control significantly reduces product deterioration. Data integration improves traceability and quality management through the supply chain. The second innovative technology is the use of artificial intelligence and predictive analytics within the production process, not only for quality control, but above all for the predictive identification of elements that can lead to secondary waste. Artificial intelligence tools can therefore be used with a number of key objectives in mind to avoid possible overproduction, to optimize the production batches, and to predict defects or malfunctions that can generate product waste. AI allow for the early detection of production defects and operational inefficiencies. Predictive models prevent overproduction and excessive stock accumulation. Data analysis optimize production batches. AI make decision making faster, more accurate, and evidence-based. Process automation and robotics technologies dedicated to the production chain can also reduce food waste and loss, especially through Industry 4.0 tools that integrate automation and data control tools. In particular, these control and robotics technologies can reduce handling errors and minimize reworking and waste during the production process. Automation significantly minimizes human error during production stages. Dedicated robotics improve the accuracy of repetitive and delicate operation. Integrating automation with digital control systems enables more efficient workflow management. Product rework and waste generation are significantly reduced. Another group of technologies that can be effectively used within the production cycle to reduce waste are vision systems and inline inspections. These are different types of vision technologies that use multispectral imaging. During the selection and calibration phase within the production process, only products that do not comply with standards are discarded. The analysis can also be extended through selection and tracking options. This is particularly useful in the production process for fruit and vegetables, including not only fresh produce, but also prepackaged packaged and ready-to-eat products, where it's particularly important to define the size of each individual product. In this sector, products that do not comply with standards in terms of size, color, or appearance generate a large amount of waste. Multispectral imaging technologies can identify defects that are invisible to the human eye. Automated sorting systems ensure consistent quality standards. Product size, color, and structure can be analyzed in real time. These capabilities reduce unjustified discards and improve production yield. Sharing industrial knowledge is a key driver of innovation, competitiveness, and business resilience. Digital technologies enable new collaborative models among companies, partners, and stakeholders. Platform, consortia, and open innovation practices make it possible to leverage data, skills, and know-how across the entire value chain. Collaborative digital platforms enable the exchange of best practices, technical data, and research results between companies, universities, and startups. Supply chain consortia promote the standardization of processes and the dissemination of enabling technology. Through open innovation approaches, companies can integrate external expertise and accelerate the development of solutions for waste reduction. Transparency and interoperability of information streams trust and enable the creation of more resilient and responsible industrial ecosystems. Industrial digital platforms are technological infrastructure that enable the collection, processing, and sharing of data and knowledge among multiple actors. They foster integration between production systems, suppliers, and customers, creating open digital ecosystems. Through common standards as APIs, platforms reduce interoperability barriers. Value emerge from network effects and the ability to develop collaborative applications. In this way, knowledge becomes scalable and reusable. Supply chain consortia are structured alliances among companies that share strategic and operational information. Their goal is to improve transparency, efficiency, and risk management across the value chain. Through shared governance rules, consortia protect intellectual property and mutual trust. Knowledge sharing enables the optimization of logistic and production processes. These models are particularly effective in complex and globalized contexts. Open innovation is based on the idea that companies no longer innovate in isolation, but draw on external knowledge. Universities, startups, customers, and industrial partners become sources of value. Structured knowledge sharing accelerates development cycles and reduces research and development costs. Digital platforms and consortia amplify this approach. The firm takes on the role of orchestrator of an open ecosystem.